Hello, hi everyone. In this video class, we are going to see a new chapter, triangles. You are familiar with triangles and many of their properties from your earlier classes. In class 9, you have studied congruence of triangles in detail. Recall that the two figures are said to be congruent if they have same shape and same size. In this chapter, we shall study about those figures which have the same shape but not necessarily the same size. Two figures have the same shape and not necessarily the same size are called similar figures. In particular, we shall discuss the similarity of triangles and apply this knowledge in giving a simple proof of Pythagoras theorem learnt earlier. Can you guess how heights of mountains, say Mount Everest, or distances of some long distant objects, say Moon, have been found out? Do you think these have been measured directly with the help of a measuring tape? In fact, all these heights and distances have been found out using the idea of indirect measurements, which is based on the principle of similar figures. Next, let us study and understand about similar figures. In class 9, you have seen that all circles with the same radii are congruent, all squares with the same side lengths are congruent, and all equilateral triangles with the same side lengths are congruent. Now, consider two or more circles. Are they congruent? Since all of them do not have the same radius, they are not congruent to each other. Note that some are congruent and some are not. But all of them have the same shape. So they all are what we call similar. Two similar figures have the same shape but not necessarily the same size. Therefore, all circles are similar. What about two or more square or two or more equilateral triangles? As observed in the case of circles, here also all squares are similar, all equilateral triangles are similar. From the above, we can say that all congruent figures are similar, but the similar figures need not to be congruent. Can a circle and a square be similar? Can a triangle and a square be similar? These questions can be answered by just looking at the figures as we have seen just before. Eventually, these figures are not similar. What can you say about the two quadrilaterals ABCD and PQRS? Are they similar? These figures appear to be similar, but we cannot be certain about it. Therefore, we must have some definition of similarity of figures, and based on this definition, some rules to decide whether the two given figures are similar or not. For this, let us look at the photograph on the screen. You will at once say that they are the photographs of same monument, Taj Mahal. But are they in different sizes? Would you say that the three photographs are similar? Yes, they are. What can you say about the two photographs of the same size of the same person? One at the age of 10 years and other at the age of 40 years. Are these photographs similar? These photographs are of the same size, but certainly they are not of the same shape. So they are not similar. What does the photographer do when she prints photographs of different sizes from the same negative? You must have heard about the stamp size, passport size, and postcard size photographs. She generally takes a photograph on a small size film, so say of 35 millimeter size, and then enlarges it into bigger size, say 45 millimeter or 55 millimeter. Thus, if we consider any line segment in the smaller photograph, its corresponding line segment in the bigger photograph will be 45 upon 35 or 55 upon 35 of that of the line segment. This really means that every line segment of the smaller photograph is enlarged in the ratio 35:45 or 35:55. It can also be said that every line segment of the bigger photograph is reduced or decreased in the ratio 45:35 or 55:35. Further, if you consider the inclinations or angles between any pair of corresponding line segments in the two photographs of different sizes, you shall see that these inclinations or angles are always equal. This is the essence of the similarity of two figures, in particular of two polygons. We say that two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. Note that the same ratio of the corresponding sides is referred to the scale factor or the representative fraction for the polygons. You must have heard that the world maps, that is global maps and blueprints for the construction of a building, are prepared using a suitable scale factor and observing certain conventions. From the definition on the screen, you can easily say that quadrilaterals ABCD and PQRS on the screen are similar. You may note that in the two quadrilaterals, a square and a rectangle on the screen, corresponding angles are equal, but their corresponding sides are not in the same ratio. So, the two quadrilaterals are not similar. Similarly, you may note that in the two quadrilaterals, a square and a rhombus on the screen, corresponding sides are in the same ratio, but their angles are not equal. Again, the two polygons, that is quadrilaterals, are not similar. Thus, either of the above two conditions 1 and 2 of similarity of two polygons is not sufficient for them to be similar. From your understanding of this class and the reference of the textbook, you can also refer the textbook and do the exercise 6.1. All the questions or one-word questions are very easy to do it. We shall see in the next class. Thank you for listening and watching my class.